So, lesson two, we're gonna be going over programming and using C Sharp for the Unity engine. So here's a little quote: the best way to get better at programming is to program more and to practice like that. And what programming is, it's basically gonna be communicating to the computer, uh, or in very advanced terms, it's basically designing and building a program for a certain function, and these are called programming languages, the different languages which we use to build stuff. So we're gonna go over a bunch of different languages. One of them is C++. This is the fastest language. It's used in game development as well as competitive programming competitions. Um, so the pros is that it's very fast and it's memory efficient as well as it's object oriented. But one of the cons is that it's difficult to learn and there's no garbage collector. So that what that garbage collector means is like if you have variables you're not using, it's still gonna contain it. So that it just builds up data and it just gets more memory intensive. Um, we don't need to worry about that though, because I probably wasn't 100% accurate. But C Sharp. So this is used for web applications and mainly game development. It's a bit slower than C++, but we use it for Unity due to its simplicity and easy to learn. Pros, common language. It's similar to Java. It's easy to learn, and we use it for Unity. Cons, it's a little bit slow, and it's not that popular. So that's one of the things. Python. This one's really good for different applications like webs and mobile, and it's also great for machine learning and data science. This one's very easy to learn, and it has a lot of libraries, so you can go from a beginner programmer to a very advanced senior engineer just from Python. But one of the issues is that it's very slow, about 5 times slower than C++. Um, this is just due to the syntaxing, but it shouldn't be a huge downside to Python. If you're really interested in Python, you should just keep going regardless. And this is Java. This is used to create many applications, and it's usually for servers and clients in a network. And the pros is that like it's easy to learn, and we teach you at ComSci as well as platform independent. So some of the cons is that it's a slow language, and that's really about it, other than people hating on it. But yeah, it's a slow language. Okay, so we're gonna be opening up C Sharp for Unity, opening up Unity from here. So what we do is we hit Unity Hub. Then I open my project, which is Unity Game Jam, and then I hit that. If you haven't created one already, so I mean that would be you. Then you hit New, 3D, and you call this whatever you want, and then you hit Create. All right, and it will take a bit, but this is how much we have worked on already in our game. This like the world. Actually, hold on.
Yes.
It's a little bit too big. It's like this, right?
Yes.
Yeah. All right. Good. So, uh, right. I gotta. You don't get it. I made a bit of modifications to the game, so we don't worry about that. Okay. So from here, we're gonna be going on to programming. So the way you create a new Unity script is you right click here and then you hit create script. And then we call this whatever we want. So we're gonna go with player movement. So we're gonna move our player. So I'm just gonna call this player move. Do not add spaces in between here. If you add a space here, it's gonna cause an error. So um, do not add a space. If it's a new word, you could capitalize it, so then it would automatically organize it. So no space. Okay, now we have Unity move right here, and we're gonna double click it, or we can right click it and hit open with. Okay, I just double clicked it, but you're gonna open up Visual Studios. So this is what it looks like when you open up Unity. It's just gonna say whatever name you want. Up here, I call this one player move, so it matches the same name. And it's gonna have void start and void update. I'm gonna go over all the elements we see here. So void start is something that is called the very first frame when the game is played. So that means everything between these two brackets is just gonna run. Void update is everything between these two brackets is gonna run every single frame. It just constantly updates, and I'm gonna go over in more detail on how that works. Okay, so we use variables in math. In algebra, it's very basic, like x equals 3, and then you plug that in, and then that would equal 5. Well, usually there's no 5 there, but like it would just be x, like 3 equals, and then that would equal 5. Yeah. But now we're going to be dealing with variables in C#, and I just realized I have already done this. So that is, you know what? That is fine. Okay, so variables in C#. So there's one type called integer. So integers are essentially values that go from negative integers to positive integers. Basically, no decimals. No, can't do decimals. That's an integer. That's a variable type. Um, they're also floats. So I'm just going to put this on the top. These are types of variables, just like variables in math. Floats are for decimal places. So you can say negative 7.5, and then you have to say F to declare it is a float with C#. And then you have to say 8 point whatever float. So whatever value you want, I guess. And the last one is a string. And a string is essentially anything between these quotations. So you can say the between two quotations, so the value is just the. You can say hi, and that would be the string, just hi. One thing you can't say though in string is I believe is this. No, not that. It's this. You can't say that. If you want to say that in a string, you have to just put it twice and then you could say it. But I haven't found an instance where I need to say this really badly in a string. But we don't need to worry about that. So we have different variable types: integers, floats, essentially decimals, and a string. And strings are used for messages and such. So the syntaxing is syntaxing is essentially how we're going to write the code and how do we communicate with the computer. It's basically like English. Like we learn how to use proper grammar. Uh, so we're going to learn how to use the grammar of the computer in C#. So syntaxing. So this is these regular brackets, parentheses. So what happens with parentheses is there needs to be a condition inside. So a condition can mean many things. So it could mean either a true or false statement, or it could be values that are inputted. So you just input values into here. We do not need to worry too much about this. This is like not like a huge deal. It will make more sense when we do it in practice. But this one's more important. So brackets. Brackets mean everything between the first one and the closing one will run. So here's some code. That means everything between this bracket and this bracket will constantly run this code. And that's the basic of brackets. Now we're gonna go into semicolons. So semicolons are basically like periods. When you write a line of code, you put a semicolon at the end of it to know that this is the end of the statement. You don't need to add anything else. You don't do this in Python, but you do this in many other languages: C#, C++, Java, Java, like countless. Okay, so we do not put semicolons at the end of these brackets, at the curly brackets. We do not put semicolons there, so do not do that. This one we do occasionally, so we'll find out later. So now that we went over the basics of programming, we're gonna be using the variable types. So int, I'm gonna show off an integer, and I should probably go over another thing. So with integers, this is how it's gonna look in code. You have your variable type. So you have your variable type right here. So we learned about integers, floats, strings, and we're gonna have the name of it. Just like how in math we call it x equals this, we're gonna have a variable type, and this is the name. So I'm gonna call this num for number, and we're gonna make it equal to a value of an integer. So it has to be an integer. It cannot be 1.1 or else that will not work. And then we have to say that's the end of the code. So that's like the period. Like the period is right here. Okay. So that's the period. And now we're going to say that right here. Num equals 1. And that is our variable called num. Okay, so we want to see our variable in action. So as mentioned with the start, when you hit start, it just it plays the very first frame when you play the game. So I'm just gonna say print. Print would print it out into the console of Unity. Let me just show you where. So this is the console, and it will print out the value in here. So I'm just gonna say print num, close it with the semicolon, and you see I use the this brackets, the parentheses, because I have to input the value into here. But we'll get into more detail later. Let's move on to the next variable type then. String name equals Alan, and you know what, that's good enough. And then it's highlighted here because I never use name. And then we're gonna put my name into print. So it's gonna say my name every single frame. Okay, as that's loading for the demonstration, I will be moving on to the next part. So we're gonna be overing okay, I guess this is important. So we're gonna be overing public variables versus private variables. So this is whether you've done programming before. This is gonna be specific to Unity. This feature. So when you use public in Unity, you're able to access this through the Unity game engine. So here we have a variable, and if we say it's public up here, that means this this variable is able to be accessed by the Unity game engine if it will load, and other scripts. So Unity has a bunch of these components with each and every single game object. So with scripting, we can alter the values of these game objects. And these are like rigid body, box collider. We can and transform even. We can change all these values using code. So that's the point of programming. We're going to be using. You're going to be changing those values. So here we have the transform, and we want our player to have the player move script. So we can drag that into here to get that to be there. Or you can just search player move after hitting add component on the bottom. So then you have player move. Okay. Thank goodness it's actually working. So here we have num, and we could see num, right? But we had two variables declared, one of them being my name, right? And that is because this one is public. Because num is public, I am able to see it as well as change the value. So that is the thing about public. When you don't say it's public, it automatically becomes private. So public variables are basically if you want to change it inside the Unity editor or by other scripts. So I'm just gonna run this this code we have. So we can see in the console that what it's going to be doing is right here. So it said 89 the first time because in the start, it only during the first frame, it prints out the number, which happens to be 89, which is what I set it into the Unity engine. Despite it saying 1, the Unity engine like changed the values. And then it printed out my name, which is here in this private string, every single frame. Okay, and now we're going to do something a bit more interesting with programming. We're going to alter the position of our game object. So if we say transform dot position equal, gosh darn this, okay, equals new vector free. All right, and this is what this code is doing is it's changing our position from here, our transform, it's changing our position to 0, 1, 0, 0, 1, 0. And I'll be go overing vectors in a second. But let's see if it works. And we could see that, yeah, it did in fact move our player by a bit. Let's see that again. That was an amazing program we made. Yeah, it dropped very slowly. I'm just gonna set this to 10. 1 is a little small. Yeah, and there it goes. That's what we made so far. So we'll be go overing vectors. Okay, this one I can erase. So vectors are different from physics. So essentially, vectors are basically holding positions. And here we have a vector free, which means it's just going to hold free values, which represent the positions. We can see that this cube, if we set it 0, 0, 0, it's our, wait, no, that's not the cube. This cube, we have, if we set it to 0, 0, 0, the current vector position is 0, 0, 0, representing the x, y, and then z. So then if we change the x, it would be negative 3, and then it will still be 1, and then 0, negative 3.03. You get the idea. So that's what a vector is. So vectors are variables the same way as strings and integers. So we're just declaring the position to be equal to this variable. New variable, we have to say new, otherwise it does not work. And that is a reason that is a little beyond my comprehension for now. But we put new into here. And then now we're going to change the position of, the player using inputs. So we have this this object with gravity and everything. So what we're gonna do now, it may sound tempting. We could change the values of the player directly using the transform and using their inputs, right? That would make sense, right? We can move the player like this if we get the keyboard inputs. The issue with using the transform is that it would result in clipping because it's not part of the physics system. So we don't modify the transform. We're gonna use the rigid body because this is part of the physics system. So let's move on to like how we get the user input. So the first thing is we want to create private variables. I can't type right now. You know what? I'm pulling out my keyboard. No, we're getting private variables called input x, and then we copy that, and then we say input y. So here we're going to declare these to be equal to input x is equal to input, which is the Unity input manager, dot get access, and then we want to put our method, our condition, which is going to be horizontal. And I'll explain this in just a sec, but here's the code. Oh wait, hold on. This is the code. There we go. So this is the code we're going to be using, and I'm going to be explaining it right now. So what's happening here is that it's going to the player settings of the Unity. Wait, no, not the player settings. I'm saying this wrong. Come on, project settings. So here's the project settings, which come default with Unity. Here's like all the settings that you can modify. Gravity, we don't change that really. And then here we have input. So this is the input manager. And here's all the different types of input we can use. One of them being horizontal. So we can just take that axis from the Unity, because right here it says it's a x-axis. So we just take that. And now we have the values of the x input and the y input. So what we're going to do now is, I'm just going to show you the bad method to doing it, to making your movement work. So input x 0, input y. So here, if I hit play with this script, we're going to be able to move our cube using the inputs we have here. So we hit play, and bam. Okay, you can see the issue with the script I just made was that the player is able to clip through the walls, and that is a result of using the transform, because it is not meant for the physics system. You can see how the ball can clip, the cube can clip through the walls, just like that. It could be a good game if that's what you really want, but I don't think that's what we want, so we're going to fix that. So as I mentioned before, we're able to access these components such as transform and rigid body. But the way you access rigid body is a little bit different, because transform comes default with every single object, as seen here. If you get the floor, transform. If you create a new empty, it's always a transform. So that's something that comes default. But here we want to access the rigid body. So now we're going to be using RB dot velocity would be equal to a new vector free, and that vector free is going to be x and then y input. And now when I run the code, it will be able to not clip through the walls. Okay, well, despite the insanely slow speed. Okay, well, it's insanely slow right now, but I'm just gonna increase the speed. So the way you increase the speed is you add another variable. So we create a variable called speed, public float speed, and what we do is we multiply these values by the speed. Okay, but currently speed is set to 0 because we have not set it to any value. The reason why we made it public is because now we can change the values in the Unity editor. So that's what we do public for. And this may be all confusing, but it gets way easier with practice and like tutorials from Brackeys and whatnot. Like in lesson 0 and lesson 1, I have like tutorials for those channels, and they're just great channels to watch if you're interested in this. So here I'm going to set speed to 10. Now we move again. That rhymed. And now you can see that despite how fast the cube moves, it does not clip through the walls like before. Of course, clipping in games is something that always happens, but here we can prevent it much better with the rigid body. Now I'm pretty sure we can still clip. I'm just going to see how high we can go before we start clipping. Okay, so that's not clipping yet. Maybe 6. Yeah, okay, so around there. Yeah, that's clipping. And I'm also flying right now. I will explain the issue with this right now. So we can see how the cube is flying, and it's doing that just fine. The reason for it's flying is because we're setting the velocity in the y to be 0. So it is physically unable to fall down because the velocity is 0. However, gravity is still acting upon it, so it would slowly fall down as its velocity is 0. So the way we stop that is we set the velocity to be equal to itself. If velocity is equal to itself, then there would be no changes to it. So let's do this again. Move this to 66 so we can clip it out and show the falling. So now I move it. Now you can see it falls normally as it's supposed to. Okay, but here's one of the issues with the code we have just wrote, and it's that on some computers, update is much faster because it can run frames way quicker. But on other computers, update is much slower because it takes longer to run a single frame. If you're running a Macintosh, this game is going to take like 1 frame a second, right? So it's barely going to move. It's not going to move at all. But if you're using a quantum computer, this is going to have insane speed because it's constantly updating. So the way we change that is by we multiply by a constant, not a constant, but this is called time.delta time. This is from the time manager of Unity, and delta time is basically it determines the time change of the computer from the last second. So basically, 1 second of time.delta time is 1 second in the real world. So we're basically making it so this would always have a constant speed, no matter what computer. And now our code will be looking like this for moving our cube. And now if we hit play, this is how it's gonna work. Let's see. I believe it's gonna, is it gonna be slower? Yeah, it's gonna be slower because we multiplied by time by delta time. And this is how it looks right now. It's very basic. It's very simple. Just a basic moving simple cube. And that's all we got. So right now it's a little bit the camera does not follow the player, and that's one thing that we added. So I'll be explaining how to add a script to follow the camera, because currently the camera is only right here. So we want to make a camera script that can follow the player no matter where it moves. So here, if let's say the player is right here, 0, 0, 0, we want the camera to always have a certain offset. So it's have 1, 1, 1, 1, 1, 0. So it's always a certain distance. And we want, if the player moves downwards, we want the camera to still follow that position. So let's say the player moves all the way over here. We want the camera to move like that as well. Let's say the player moves over here. We want the camera to do that as well. So it's always going to constantly be this same distance. It's always going to have an offset to it in this world space. So basically, it always has a constant vector that it adds on. So here we have 0, 0, 0. If we add a vector of 1, 1, 0 to it, that means no matter where the player goes, if we just make our position of the camera equal to this plus the offset of 1, 1, 0. So here we have the player plus 1, 1, 0. That equals that. Offset plus 1, 1, 0. The player position plus offset equals that. So we're basically going to get the player position, and we're going to get a specific offset to it. Let's create a script for that. I'm going to hit add component camera, and no space. We say scripting. I already have a camera script. I'm just going to call this one camera move then. So no space. If you just make the second word capital, it automatically creates a space. And you gotta wait a bit for it to be created, and then you edit script. Now we have a new script. I'll be going over how to make it right now. Public transform. So we want to get the position of the player. Call this one player. And then we want a specific offset. That's a vector free. And this may be confusing, but it will make sense if you practice. And don't worry too much. And we're going to make our transform of the camera be equal to the player position plus the offset that we have created. So then the camera has the script. We're going to drag the player into here, and then we're just going to get our current offset. And the way you get that is let's set this to 0, 0, 1, 1, 0, 0, 0, 0. I'm just going to set this one to 0 as well. Okay, so this is how our offset looks. It's a Y, 7.4, and then 10. Okay, so that's how it looks. We put that into there, and then once we start following the cube, once we start moving the cube, we follow it constantly. And that's currently all we got so far done in programming. And next lesson tomorrow, we're going to be reviewing programming, so everyone can get a good refresher. Quickly, just because we speed ran programming, we went through it very quickly, so I think a review period would be great. and I think sleep would be good for me as well.